Welcome to Exploring the Risks in Current Wireless LAN Deployments. My name is Brian Reed. I'm the Security Practice Manager for Connexus Communications Limited. This is a four-part series which discusses the real risks to your wireless networks. Part 1 dealt with the series introductions and risks within open networks. Part 2 is going to discuss risks within WPA2 personal networks. Just to recap what we talked about in Part 1, I'd encourage you to go back and view Part 1 if you haven't already. Essentially, we're building out this 3x3 grid with the different attack vectors across the top, that being sniffing, attackers gaining local access, and attackers impersonating your network, and with the different types of wireless networks down on the left-hand side, that being open hotspot, WPA2 personal, and WPA2 enterprise. So in Part 1, we talked about the open hotspot network and sniffing and local access attacks on those networks. And today we're going to be talking about WPA2 personal, sniffing and local access attacks. So WPA and WPA2 personal use a shared password on a wireless AP and shared passphrase on the client. So the client and the wireless AP have a shared password between them, and that's used to trigger the encryption and authentication. So for an attacker to sniff or join the network, they would need the passphrase. They can't simply set up a sniffer and sniff the traffic without the passphrase because that traffic would be encrypted. So that sets up the attacker to try and steal the password or otherwise gain the password. So I always like to point out that first of all, the easiest way to steal the password is from the user themselves, either through social engineering or some other technique. This is often overlooked when we're talking about some of the more sophisticated threats to WPA2 personal, is that by definition, as soon as you've set that password, you then have to give it to people. And once you've given that password out, the password is no longer 100% secure until you've rotated it again. Attackers can also steal the password from the client system. Most people don't realize that client systems, for the most part, depending on what operating system and what wireless provider you're using, store wireless passwords for the duration of its existence in the registry. So, for example, I'm running this wireless key view application from nearsoft.com. Excellent application that if you can get that onto a laptop and run it, as I've done here, it will expose all of the wireless networks that this person is connected to over the last period of time. And I've removed the columns from here, but it also displays in plain text the passwords that the organization, or the person rather, has used to gain access to the wireless network. So this is an excellent program, and it's a good demonstration that it's also possible to steal WPA2 passwords from a client if you ever lose a client or if you ever gain access to a client. If an attacker is unable to steal the password from the user or from the client system, then they must go ahead and try and crack the password. And this is the threat that we're going to be focusing on today, even though it's probably less likely that an attacker would crack the password than they would just try and steal it from a user or the user's system. So WPA2, I'll just give you a little bit of background on how it works, just at a very high level. WPA2 personal basically starts off with an association request and a response to join the network. And then the key to the WPA2 encryption exchange is a four-way handshake, and that installs a session key. So the client provides the passphrase, the access point validates the passphrase, and then together they establish a session key. So moving forward, all of the traffic is encrypted. So you'll see that up until the encrypted data flows start, the traffic is not encrypted. So the handshake itself is unencrypted. Now you can't see the passphrase in that handshake, and you can't see the session key in that handshake. However, you can use the captured traffic to perform some attacks against WPA2. So there's a lot of research that went into this, and there's a lot of sophisticated applications that go into attacking the WPA2 personal handshake. But the bottom line is the captured handshake gives you enough information to conduct a password guessing attack against the network that you just captured the handshake on. So if you're an attacker, you're going to want to capture that handshake, which is fairly straightforward to do, and then you're going to want to gain access to a tool that allows you to start guessing at the passphrase and using the captured handshake to validate your guess. And this type of process has been automated through several tools, and you can run numerous passwords through a dictionary attack against your handshake, and eventually, if the passphrase is in your dictionary rather, you will discover the actual passphrase. So to illustrate that fact, I've set up a demo which talks about cracking a WPA passphrase. So I'm going to be using the AirCrack NG suite again, and I'm going to show you how to capture a four-way handshake, the WPA personal handshake, with a tool within that suite called AirDump NG. And then I'm going to attempt a dictionary attack with a tool called AirCrack NG. And this is the most common way that attackers are currently gaining access to WPA2 personal networks by cracking the password. Okay, in this demo we're going to be showing you how to capture a WPA2 PSK password. So in order to do that, I'm going to set up the demo. I'm going to create a wireless network running WPA2 PSK. So we'll call it WPA PSK demo as the SSID. I'll choose a fairly simple passphrase, Connexus demo, as the passphrase, and we'll enable WPA2 personal security on the network. So I'll go ahead and apply that and create that wireless network. So now we've got a WPA2 PSK network, and I'm going to show you how to capture a user's handshake and then crack that handshake. So I'll maximize my screen here. So the tool we're going to be using to capture the handshake is called AirDump NG. Syntax looks like this. And essentially what that's doing is it's starting the tool on channel 10. It's going to look for particular BSS ID so that we can narrow down our capture results. And it's going to write to a capture file called Connexus demo. It's going to capture on our monitoring interface of monitor 1. So that's the syntax of the tool. And essentially when I run it, it's going to tell me everybody who's joining the network, which is essentially nobody right now. It's going to tell me the name of the network, and hopefully if I can capture somebody joining the network and exchanging their passphrase, then it will give me a status indicator on the top right around here that will tell us that somebody has joined. So I'll go off camera now and I'll join the network from one of my clients. So here I'm joining the network right now. I'm going to type in the passphrase of Connexus demo. And there you see a few things happened on our screen. So as soon as my client joined, it registered that they had joined. It also captured their WPA handshake, which in and of itself doesn't necessarily allow you to break into the network, except that now that I've captured the handshake, I can execute a attack on that password by doing guessing dictionary words, dictionary passphrases against it. So just to show you what I captured, I'll open up Wireshark again. Open up the packet capture. And we can see right here that I've captured the four-way handshake. So that's just validation that I've got the packet capture within my file. So I just wanted to show you that, but the purpose of this particular demo is how to attack that handshake and start guessing dictionary words against it. So to do that, I'm going to use a tool called aircrackng. And the syntax for that particular command, what you're going to need is a custom dictionary, which I've defined with my own selection of words that I would consider to be likely WPA2 PSK passwords. And you run aircrackng with the dictionary file stated, the client ID, and the name of the packet capture that you're going to be capturing against. So let's go ahead and run that. So now it's going ahead and trying all sorts of different passwords through my dictionary file to attempt to find the one that's was captured in the handshake. So you can see it's going at about a rate of 350 or so per second. That can go up or that can go down depending on the speed of your system. And you can see that within a matter of about 10 or 15 seconds, it's found that the actual passphrase was Connexus demo. That was in my dictionary file, fortunately, as a likely choice. And in a matter of about 15 seconds, I was able to run a dictionary attack against the handshake and actually discover what the WPA PSK was. So there you have it. That's how you would capture a WPA2 PSK password using the AirCrack suite. So what did we learn through that demo? Essentially, that was a dictionary attack, and if the passphrase was not in my dictionary, then the attack would not be successful. So that's a key point. So the success rate of the attack has a lot to do with the rate at which you can guess passwords and the size of your dictionary and the accuracy of your dictionary. So just to give you some real understanding of the risk here, I was able to guess about 1,000 keys per second on my fairly basic system. And when I go on site and attempt to gain access to a WPA2 personal network, I develop my own custom dictionary, which has a higher probability of success for that organization. So just to give you some background on that, I would start out with about 10,000 common English words, and then I would supplement that with industry terms. I'd maybe go through the customer's website and pull off a bunch of technical terms and specific terms about the geography, the city, the location, the address, things unique to that customer. And I would supplement that to gain about 14,000 words in my dictionary. Based on that base dictionary, I would then modify it to include 10 prefixes and 10 suffix words. So those are the little words that people tend to put in front of their passphrases to make it a little harder to guess. So for our wireless network, if our company was called Connexus, maybe I would use the passphrase Wi-Fi Connexus or something like that. So to account for that, I would pick the 10 most obvious prefixes for that organization, the 10 most obvious suffixes, and multiply my dictionary out through those prefixes and suffixes. So the dictionary would really start to grow. I'd throw in some capitalization variations. That's another common thing people do, 0 for O, things like that. I would put some things on the end. Sometimes people tend to put numbers or exclamation points or something on the end of their Wi-Fi password. And then I would also put in some capitalization variations as well, capital first letter, capital last letter, those types of things as well. So by the end of the day, I should get about 3 million entries in my dictionary, and I can run through that on my simple low performance system in about 80 hours. So that's a good yardstick for an attacker with a very low end kind of machine and on a very limited amount of time to attack your network. So what if the passphrase isn't in the attacker's dictionary? Their attack's obviously not going to be successful. So a common question that I get is it possible to simply brute force that passphrase and just try and guess every possible passphrase until they get the correct one. While that is possible through some password guessing attacks, it's not really practical for a WPA2 personal attack, at least with the current state of technology as it is today. For an 8-character passphrase, if you do the math, that would take 170,000 years on my system. My system's fairly low performance though, it's used for demos. But what about on an optimized personal system? Or what about in a multi-processor environment or cloud computing? There's been a lot of talk on the internet lately about people using botnets with 10,000 processors to conduct WPA2 personal brute force password guessing attacks. And even though you can reduce my 170,000 years by multiple orders of magnitude, really the state of the technology as it is today is that brute force attacks are not particularly practical. Maybe they'll get to the point where they could be practical over 8-character passphrases, but of course you can go much higher in terms of your passphrases in WPA2 personal, and I would encourage you to do that just to be on the safe side. That's not to say that other attacks are going to emerge in the future and performance increases will emerge in the future. So things like rainbow tables where attackers are pre-computing passphrases and doing the arithmetic for you in advance, and then you simply download the tables and use them as a lookup. Again, that's a performance increase, but it's not enough to change the ultimate risk profile, which is brute force attacks are not particularly practical once you get into longer passphrases. So while a complex passphrase can't provide absolute security, it can provide pretty reasonable security from brute force password guessing attacks. You just have to make sure that your passphrase is not in any attacker's dictionary or cannot be put in there logically by the attacker. So if we're going to summarize our risk discussion regarding WPA2 personal, first of all, I'd encourage you to understand the shared password dilemma, and that is from the time you set your wireless password to the time you start to tell people that password, and that password gets distributed throughout your organization, through your boardroom, through your guests, that password will eventually become known, widely known, and can be stolen or learned outside of your organization. So unless you're frequently rotating that, which I find is not usually the case with most organizations, that password is out in the field for attackers to discover. So right away, I'd like to identify that non-technical risk as something that you need to take into account. Of course, if you're comfortable with that risk, then I would encourage you to choose a difficult to guess password. You know, the first hurdle is make sure that it's complicated enough that it's not going to appear in any attacker's dictionary. And dictionary attacks are fairly fast. You can have fairly large dictionaries, but it's also very straightforward to choose a complicated passphrase that is not logical for any attacker to have in their dictionary. And that should be your goal when you're setting your wireless password. Longer passwords will resist brute force. So even though while I said that even with all sorts of technology enhancements now, brute force attacks aren't particularly practical, it's difficult to say what the future holds for that. So best to choose longer passwords, and those will have increased resistance to brute force attacks. So if I'm going to assign a rudimentary score to this type of vulnerability likelihood, the difficulty to exploit a sniffing or an association attack on WPA2 personal network can be anywhere from 3, which is highly likely, to 9, which is not very likely at all, but it's dependent entirely on the secrecy of your pre-shared key, and of course, keeping that pre-shared key secret is a bit of a chore. So you may find that within your environment, the vulnerability likelihood could be fairly this vulnerability could be fairly likely within your own environment, depending on how you're managing your key. The ease of detection of this particular attack is very difficult to detect someone joining your network or sniffing your network once they've recovered your passphrase, mainly because these attacks all take place offline, and capturing the handshake is all you need to have that offline attack, and capturing the handshake is pretty much not detectable. So if I was going to go back to my color scheme just to track our progress in a very visual way, sniffing and local access attacks on a WPA2 personal network are entirely dependent on the secrecy of the PSK, and are moderately likely to take place. But again, that depends entirely on how you're securing your PSK or pre-shared key. So that concludes part 2. Thank you very much. Please stay tuned for part 3, which discusses the risks within WPA2 enterprise networks. My name is Brian Reed, and if you have any questions about the products or services offered by Conexus, please visit our website at www.conexus.net.